Alright, so next we're going to plot the log 4 of x. And for that, since it's like a parent function, you know that your point is going to be, your point is going to be 1 to 0. So let me just label that. And then, you know, the vertical asymptote would be, x equals 0, sorry. And so it'll go up like this, and then it'll continue out like that. Because it's a log function, it would not have a horizontal asymptote, so you don't have to worry about that. Alright, so next we're going to consider this function. Log to the base of 2 is 7 minus log to the base of 2 x minus 2. And for the domain, first you want to make sure you don't worry about this log base of 2 is 7 because that's a coefficient. And so all you're doing is looking at this one. And for this one, the x minus 2 is greater than 0, plus 2 on both sides. And so your domain would be 2 to infinity. And so that's what you put here. And then you want to make sure that it's exclusive. And for your vertical asymptote, it's the same as up here, where you were looking at y equals 0 x-axis. And so for that one,
you're welcome to go from I don't know.
Oh, excuse me for that one. Actually, you're looking at the domain, and since the domain starts at 2, your vertical asymptote would be x equals 2. Then your anchor point is where you actually set that equal to 0. And so it would be 0, log base of 2, 7 minus log base of 2, x minus 2. And so this, I do log 2 of 7 on both sides. And so negative log 2 of 7 equals negative log 2 of x minus 2. And then you can just cancel out those minuses. And then it'll be 2 log 2 of 7 equals x minus 2. And since the log base of 2 and the 2 cancel out, you get 7 equals x minus 2. And then plus 2 on both sides. And then you get x equals 9. And so that would be your anchor point, 9, 0. And then next you're going to approximate this value, log base of 2 is 7. And so for log 2 is 7, to approximate that, what I did was equal that to x. So I did 2 to the x equals 7. And I figured 2 squared equals 4, and then 2 to the third equals 8. So it has to be something in between that. And so between 4 and 8, probably get around 2.8 as approximation, since 7 is closer to the 8 than it is to 4. So, and then next you use information up here to plot that function on the graph. Alright, so you know your domain is from 2 to infinity, so you don't want to breach that line. Next, the coordinates of the anchor point. You know your anchor point is 9, 0, so 1, 2, 3, 4, 5, 6, 7, 8, and then 9 is up here. And then you just go down the vertical asymptote and hit that, and you keep going. And it does not have any horizontal asymptotes, so you don't have to worry about how far down you go. And then you want to solve this equation, and for that, it'd be log of 2x plus 4 equals log 2, 7 minus log 2 of x minus 2. And since first you want to make sure that both sides have 1 log on there, and so for this you can simplify that. So it'd be log 2x plus 4 equals log base of 2, and since it's minus, you know you're dividing here, and so it'd be 7 over x minus 2. And so for that, then you cancel out the logs, because you put logs on both sides. So it'd be x plus 4 equals 7 over x minus 2 times x minus 2 on both sides to get all the x's on the same side. x plus 4, x minus 2 equals 7. Then x plus 4 equals 7, x minus 2 equals 7. And then you'd get x equals minus 4 plus 2 plus 2. Get x equals 9 up here. And then x equals 3. And then you'd plug these into the equation that you had up here to make sure they're right. And so the log of 2, 3 plus 4 equals log of 2, 7 minus log of 2, 3 minus 2. 3 minus 2 is 1. So log squared of 1 is 0, so that would go away. And so 3 plus 4 is 7, so it'd be log squared of 7 minus 7. Equals log squared of 7. And those equals, so this one's correct. But when you try to plug in log of 2, 9 plus 4 equals log of 2, 7 minus log of 2, 9 minus 2, 9, 10, 11, 12, 13. You get log squared of 13 equals log squared of 7 minus log base 2. Apologize, 97. And so those two would cancel, and so you're left with that equaling 0, and that's not the case, so this one's wrong. And so your equation, the answer is 3. And so the solution relates to the graph above because that's where they intersect at. The intersection point is at is where x equals 3. And so that's how they relate.